Hello there again. Today we're going to talk about a couple of formulas. The first one we're going to look at is the distance between 2 points. How do we find the distance between 2 points, let's say one point x1, y1 and the next point x2, y2? Well, we have to make a triangle first of all between these 2 points, like this. Notice that this triangle is actually a right triangle. And we know properties of right triangle that relate the hypotenuse, which is the distance we're looking for, to the rest of the sides. The hypotenuse is actually the distance between x1, y1 and x2, y2. So let's call that distance c. The Pythagorean theorem tells us that c squared is equal to a squared plus b squared, where a and b are the other two sides of the triangle. If we look at this side of the triangle, the horizontal side, we can see that this distance here is actually the difference between the x's. So this distance here is x2 minus x1. Similarly, if we look at the vertical distance, that distance there is y2 minus y1. Now we can derive a formula for the distance between the 2 points. And how do we do that? Well, according to the Pythagorean theorem, c squared is equal to a squared plus b squared. Well, a in this case is one of the sides, which I'll call x2 minus x1. We'll say that's a squared, plus b squared. B squared is the other side, so that's going to be y2 minus y1. y2 minus y1 squared. And so that's c squared. But we're actually looking for c, the distance between the 2 points. So I have to square root both sides. However, when I square root a square, what happens? When you square root a square, that disappears. And so we're left with c, the distance between the 2 points, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, in math, we normally call this distance d. So I'm just going to change this to d, because that's what we're used to. And so that's the distance formula between 2 points. Let's take an example of applying this. We want to find the distance between 2 points, the point -2, -2, and 4, 2. -2, -2, and 4, 2. My distance formula here says the distance is given as the square root of x2 minus x1 squared plus y2 minus y1 squared. So we plug this into our formula, we get distance is equal to square root of the difference in x's. So I'm going to take this minus this, 4 minus minus 2, 4 minus minus 2, 4 minus minus 2 squared, plus the difference in y's, 2 minus minus 2, plus 2 minus minus 2 squared. We calculate this out, so the distance is equal to 4 plus 2. 4 minus minus 2 is 4 plus 2. That's 6 squared plus 2 plus 2. That's 4 squared. So that's equal to the square root of 36. 6 squared is 36 plus 16. 16 is 4 squared. And if we add them together, we get the square root of 16 plus 36 is 52. Okay, so our distance is the square root of 52. Now, we can actually simplify this. Note that 52, if you think of 52, 4 goes into 52. 4 goes into 52 13 times. So this is actually 4 times 13. And we can square root 4 as 2, so this is actually 2 root 13. So our answer is 2 root 13. So my distance I'm looking for is 2 root 13. Now, if you want a decimal equivalent of this, we can find a decimal of this, plug it in our calculator. 2 root 13. That's approximately 7.21, approximately a rounding that. But here's a good use of the distance formula. Suppose we want to find the midpoint between 2 points, like the middle between 2 points. Here you have 1 point, here you have another point, and you want to find that point right in between those two. Can we find that? And yes, we can. We can use a formula to find that. We can derive a formula. And actually, it's quite simple in the sense that this midpoint, right in between the 2 points, right here, it means it's equidistant from each point. That's why it means to be a midpoint. That midpoint is actually the averages of the x's and y's. So in other words, that midpoint, the coordinate of that midpoint, is the average of the x values, x1 plus x2 over 2, and the average of the y values, y1 plus y2 over 2. And so that's how we find the midpoint between 2 points. Notice it is a coordinate point. Let's take an example. Here's a question that says, find the midpoint between the 2 points negative 2, 5 and 3, 1/2. Negative 2, 5 and the point 3, comma 1/2. So the midpoint formula says, to find that midpoint, take the averages of the x's, take the averages of the y's. Okay, so what we'll do is we'll take x1 plus x2. We'll have negative 2 plus 3 all over 2. Negative 2 plus 3 over 2. That's the x-coordinate. And the y-coordinate is going to be 5 plus 1/2. 5 plus 1/2 over 2. Now we do need to simplify this a little bit. If we add the x's, negative 2 plus 3 is 1. Divided by 2 is 1/2. So this is going to be 1/2. And then 5 plus 1/2, that's going to be 5 1/2, not 5 halves. 5 1/2 divided by 2. 5 1/2, on the side here, thinking 5 and 1/2, that's equal to 2 times 5 is 10, 11 halves. And we have to now divide that by 2. So we have 5 1/2 divided by 2, 11 halves divided by 2 is 11 quarters. So 11 quarters. And 11 quarters is, if we simplify this, what is 11 quarters? Make it a mixed fraction. That's going to be 2 3/4. So just so we know, this is our scratch paper work here. Okay, so our midpoint is at 1/2, 2 3/4. That's the coordinate of this point right here. 1/2, 2 3/4 is our midpoint. We call it M.